our agenda for today is, first I will give a very quick overview of Galera Cluster, and then we will discuss in detail how it compares to traditional asynchronous replication, what is different, and what you should watch out for when you migrate your applications. And finally, if time permits, we will have a short demonstration on an actual migration. So first, Galera Cluster is a synchronous multi-master application for MySQL. Synchronous meaning that each transaction is immediately replicated on all the nodes at commit time, and there is very limited to no slave lag, and there is no opportunity for any slave servers to become stale or fall very behind the master in any way. It is also multi-master, meaning that you can read and write from any node, and the product includes automatic transaction conflict detection and resolution, meaning that even if you make conflicting updates on two different nodes, this is not going to cause an inconsistency in the cluster. The situation will be detected, and the appropriate error will be returned to the application. It is a replication solution in a sense that a copy of the entire data set is present on all nodes. It does not currently perform any sharding of the data. So each query can be answered by any node, and new nodes can join automatically with all the details about how the data set is shipped to the new node and synchronized. All of this is handled internally by Galera. So there is no need to perform any manual operations to transfer the data. And finally, it is based on a modified version of MySQL. We provide packages for 5.5, 5.6, and 5.7 will be coming up. And it is based on the InnoDB storage engine, meaning that all data is stored in InnoDB. So any performance optimizations that you have made, any knowledge about InnoDB and how it performs and behaves applies immediately to Galera. For example, as opposed to a MySQL cluster, which uses a totally separate storage engine and where queries behave in a very different way. Furthermore, the product has some really nice features. It recovers from node failures within seconds without the need of a separate procedure to promote a new master from an existing slave or anything like that. And it has very strong data consistency protections in a sense that the application is prevented from reading stale data and or making unsafe data modifications. It also works in the cloud. It works across data centers, across countries, and across continents, and it provides end-to-end encryption between the different data centers, and the entire communication protocol is optimized to deliver replication with the least possible latency. So there are no excessive round trips when replication happens, apart from what is strictly necessary to send the data over to the one. Okay, so first, synchronous replication means in practice. It means that the actual replication between the nodes happens at commit time. So when a transaction is committed, then Galera will take all the writes that are performed by the transaction and ship them over to all the other participating nodes. This means that there may be some delay at commit time if the network does not perform very well, but it can also allow you to avoid disk I/O altogether at commit time if your nodes are sitting on independent power supplies, for example. And the other special thing about synchronous replication is that it virtually eliminates slave lag. So nodes are only allowed to be behind the master by only a few transactions at a time, and this is strictly a performance optimization. It is not possible for a slave to lag, for example, a minute or two behind the master. And if the cluster detects that a particular node is slow, then the entire cluster will be throttled a bit until this node has had the opportunity to catch up. And this has the practical implication that if your current replication topology exhibits a lot of slave lag, when you migrate to Galera, your master will start to be throttled in order to make up for those slower slaves. So this is one thing to keep in mind when you migrate, that the actual behavior of the commit procedure is different, and you cannot simply pump transactions on the master as fast as it can handle them, and let the slaves catch up at a later time. Since all the nodes in the cluster work together as a single entity, you cannot have one of the nodes being very far behind the others. Galera is multi-master, and each and every Galera node can process any database update. And if you issue conflicting transactions on different nodes, those conflicts will be detected at commit time, and an error will be thrown. So if you would like to take advantage of this capability, then the application must be capable of detecting errors at commit time and retrying the entire transaction. If the application currently cannot do that for one reason or another, you can still use Galera in a single master mode. You can still direct all your updates to a single node, and then just take advantage of all the other benefits that Galera provides. And one of them is that since all the nodes are fully caught up to the master at all times, the failover is instant. As soon as one node goes down, the other nodes will detect the situation using a very simple, very short timeout, and you can then send your queries to the other nodes. There is no need for an external procedure or a monitoring script that will promote a new master from one of the slaves or anything like that. So even if your workload is not multi-master internally, it can still benefit from the fact that all the other nodes are standing by at all times to be masters. And you are free to use any load balancer to spread the queries around. Codership maintains a TCP level load balancer called GLB, which does not have deep knowledge into the actual queries that are passing through it, but you can also use a load balancer at the query level to split your reads and writes if you want to. And for some languages, the default MySQL connectors are able to use more than one server at a time. So you pass a list of your Galera nodes to the connector as part of initialization, and then the connector will automatically switch to the second node if the first one fails. With respect to monitoring and configuration, the entire Galera configuration is stored in the my.cnf file. So Galera does not use the change master command for MySQL, and it does not use files such as master.info, relay-log.info, or any variant thereof. And the show slave status command is not used to display the status of the cluster. Instead, we have a set of variables that provide useful status information, and the most important ones are Recep cluster status, which shows the status of the particular node and whether it is currently part of the cluster or disconnected for some reason. And the other important variable to monitor is Recep flow control post, which shows the percentage of time that Galera had to implement throttling in the cluster because a slave could not catch up with all the a node could not catch up with all the replication updates. Then we should talk about how Galera and the binary lock interact. From traditional replication, you are used to having binary locks being shipped around and used, but in Galera, the binary lock files themselves are not used. So Galera still uses the row-based replication events, but it uses an internal mechanism to ship them and to store them and to apply them on the other nodes. So there is no need to actually store the binary log files for Galera. If you need the binary log files for some other purpose, for example, for taking backups, then there is an option called log slave updates, which ensures that any update made on any node in the cluster will be reflected in the binary log of all the other nodes. So for backup purposes, for example, you can only use one of the nodes, and its binary log will contain all the updates that happened in the entire cluster. But if your backup scheme does not require the binary logs at all, and if you have no other use for them, then you can disable writing those logs to this code together. And Galera will handle the replication internally. Galera strictly uses row format, binary log format row, meaning that it replicates and applies individual updates that are made by the transaction on the individual rows. It does not replicate statements. And there is a separate option, recep forced binlog format, which you can use in case you have an application that you suspect may be trying to mess up with the binary log format internally. When it comes to adding new nodes, or what was in synchronous replication, adding new slaves, with Galera, there is no need to manually ship your data files, so there is no need to manually track what position your replication should start from and all of that jazz. Galera will internally take a snapshot of the database from an existing node, ship it over to the new node, and do whatever is needed to bring this new node up to speed. So this reduces the need to have scripts, the need to use some additional tools just for the purpose of adding new nodes. It is all handled internally in the product. Then Galera cluster can coexist with existing replication. A Galera cluster can be a slave to a traditional replication, which means that it can receive updates from a traditional asynchronous master, and it will replicate them to all Galera nodes. This is a very useful feature during migrations, and we will use it later in this presentation. And you can have a Galera cluster running in parallel to your existing replication infrastructure and receiving updates from your existing master. And Galera can also be a master to an asynchronous replication. So if you still need to have traditional asynchronous slaves for some reason, because you want to ship the data to a non-InnoDB storage engine, or you want to have a time-delayed slave, you can still achieve that. And all the updates made on any Galera node will be sent to your asynchronous slave. So now we will try to demonstrate an actual migration procedure. So the way this works is first we will convert one of our asynchronous slaves to Galera, and we will start a single node cluster, so to speak. Then we can build up the cluster to the desired size. We recommend having at least 3 nodes, but in this demonstration we only have 2 for speed. And then what remains is to switch your readers to start reading from the cluster, and then you switch your writers to start writing to the cluster. And once you have done that, it is possible to deactivate the asynchronous replication altogether. And your data will now be all in Galera Cluster. So here is how it looks in a picture. To the left, we have the situation that people would usually start with. So you have your traditional asynchronous replication with a single master replicating to several slaves. Your writes go to the asynchronous master, and your reads go to the slave. But after a migration, we'll have our writes going to our Galera cluster along with our reads, and the asynchronous master and the other asynchronous slaves will no longer be required, so you can decommission them. Okay, so let's try to demonstrate this thing in practice. Okay, so first we have our asynchronous master. It is just what you would expect. It writes to the binary log. Then we have an asynchronous slave. Again, as you expected, it shows slave status, reports that replication is running, and that the slave has caught up with the master. So starting with this, we will now convert this slave node into a single node Galera cluster, and we will temporarily preserve the existing replication until we are able to turn off the synchronous master altogether. So in order to do this, we will first shut down the slave. Okay, so now that we have done this, we have kept the existing master and any additional asynchronous slaves that existed. So those are still up, and they can continue to process requests from the application. We are just shutting down these individual nodes. Then what we need is to remove the existing MySQL server packages. So let's see. Yes. So now we are going to replace those packages with Galera enabled packages that you can download from our website. For speed, I have already downloaded the required packages myself, but it is also possible to configure a Galera repository in your system, which would allow your package manager to automatically fetch and install those packages. So there would be no need to do any manual downloads in this case. So what I'm going to do is install those packages. Hopefully this will work out. Maybe there will be some dependencies to be satisfied. Yes, we need to remove some more of the existing Okay, so hopefully now the installation will proceed. So as you can see from this directory listing, we provide packages for the server, for the client, and we also provide another package called Galera, which is the actual replication library that performs the actual replication. So in addition to replacement packages for the MySQL server and client stuff, you would also need this Galera package on your system. So once we have installed them, before we start the server once more, we will add Galera specific configuration lines to the configuration file. Okay, so first we have this server ID equals 2, which is left over from the traditional synchronous replication. We keep it, and then we add some lines that are important for Galera. So first one is work slave updates, which was mentioned during the presentation. It ensures that any updates that arrive on Galera from synchronous replication will be replicated to all the other nodes. And all the binary logs on all the nodes will be kept identical. Then we have to have the binlog format directive. This one is required for auto increment tables. And then we will have the recipe provider directive, which indicates the location of this Galera replication library that we installed in the Galera package. So when this Galera enabled MySQL server starts, it will look for this library and it will load it, and replication can then begin. And finally, we need to have a line called recipe cluster address, which basically specifies the list of nodes that we expect to be present in the cluster. So since we will do this demonstration with 2 nodes, our list of IPs here, those can be also host names, will contain just 2 IPs. So those are the 2 nodes, the 2 machines that will be nodes in our Galera cluster. So that's basically it. Those are the only lines that are needed to get Galera up and running. So we have the actual location of the provider library, and then we have the list of nodes that will participate in the cluster. When you add additional nodes later, you can modify those lines and extend them as needed. This can also happen without shutting down any nodes or restarting the cluster. Now that we have the configuration in place, what we need to do is to start the MySQL server once more. The special thing about this is that now, since this is the first time we are starting new cluster, we are passing this option to the service command, which will instruct this node that it is the first one from a cluster that we intend to build up, and it will start accordingly. This is only used the first time you start the first node of the cluster. Otherwise, all the remaining nodes can be stopped and started without any additional arguments. So let's see if this will work out for us. Okay, so what we have here, let's log in. First of all, we still have our existing replication running, our existing asynchronous replication running. So if the master would receive additional updates, we will still get those updates on the slave. But in addition to that, we also have Galera up and running. So if we do like this, we will now see a bunch of status variables that come from Galera. So what we are looking for here is reset cluster status equals primary. This means that this node is a fully fledged member of the cluster. And we also have this reset cluster size, which shows us that this is a single node cluster right now. So what we can do here is we can go to the asynchronous master. And we have a table here already. So if we insert a value into this table, we will see that this value is still being replicated using the synchronous replication to our newly created single node Galera cluster. So we now have the table, and we now receive updates from the master. So this node is already has the data and can serve it. Now what we will do is extend the cluster with another node. So now we go to a node that doesn't have anything on it, that we use for our second node in the cluster. As before, we will install the required packages. The package can be installed, so now we need to modify the my.cnf file. So what we are going to do is just take the entries from the first node and copy them over to the second one. Like this. So the nodes in a Galera cluster should ideally have exactly identical configuration, since they all serve the same purpose. So now that we have this configuration in here, we can simply start the service again. We do not use any special options in here because the cluster has already been created, and we can just start the second node. What happens here behind the scenes is that the second node connects to the first one and arranges for the data set to be shipped over, all in the background, without us having to do any manual copying of any files. And what we have here is a node in a status of primary, as it should be, and now the cluster size has increased to 2. So now those two machines are in the same cluster, but they still receive updates from the synchronous replication. So if I insert another node, another row in this table here, then I can see that this node has been replicated through using traditional synchronous replication to the first node in the cluster. And I can also see that this row has also been replicated now using Galera to the second node in the cluster. And also the data that existed before has also been replicated. So now what we have is we have a fully functioning cluster, and all the data is being fed into it. So now we can just stop the master here, because we can send our traffic to the cluster directly. And on the master, we can issue stop slave, because we no longer need traditional replication. So slave status now reports that we have shut down the master. We can issue reset slave altogether here. And now this is a two-node cluster that can process updates. So we can go here into our table and insert some other value. And now we can see that this value has been replicated to the second node. So by turning off the master, we are now free to repurpose this server for something else, for example, for installing a third node. And notice that during this entire process, the application could run at all times. So there was always a server that was able to process its updates, and there were always servers that were able to answer any select queries. So there was, theoretically, there would be no downtime in a migration scenario like this. Even though we did not have an actual application running, we only had our inserts here. We always had a node or a server where we could execute them, and they were never lost. So now we have our Galera cluster running, and it has all the data from before and after in it, and the application can continue to run using Galera cluster only, and all the components related to asynchronous replication can now be turned off. And we can now even restart our first node if we need to remove any master.info files and any binary logs and relay logs and things like that if needed, because they will no longer be used. Okay, so that was the demonstration, and now we can take questions. At the top right corner of your screen, there is an orange arrow. If you click it, it should give you an opportunity to ask questions, and we will try to answer them as they come. Okay, first question is MySQL 5.1 supported with the latest version of Galera? The answer is no, unfortunately. We do not provide packages for MySQL 5.1, but you can migrate to say MySQL with Galera 5.5 or 5.6 using the same procedure, because MySQL 5.6 can be a slave to a MySQL 5.1 master, if I'm not mistaken. So the procedure still applies. Okay, next question is, how do you migrate for NDB cluster to Galera cluster? The first and foremost thing to check is whether your application will behave as you expected using the InnoDB storage engine. Because the NDB storage engine has different performance characteristics, it answers some queries using different optimization strategies. So the execution time of those queries can be different from the one in InnoDB. So once you have established this, the migration path is to dump your database using, for example, MySQL dump or some other tool, and then import it into the Galera cluster after you have created your first node. So you first create your node, then you migrate, then you dump the data, and then you can add additional nodes and they will get copies of the data. If you want the migration to have no downtime, then you can still use the method that was demonstrated in this presentation. On your master, the tables will be NDB, but then on the slaves, you can have the updates arrive via synchronous replication in an InnoDB table. This will be slightly more complicated to arrange, but it would be possible with a manual effort. You can also use outer table to convert your tables internally from NDB to InnoDB, but this needs to happen before you involve Galera replication, because Galera only works on InnoDB. Okay. Let's wait for a minute or two for some more questions if they arrive. We have our discussion group, which you are welcome to subscribe to. And on our website, you can find extensive documentation and additional migration advice. And you can also find our packages there. And as I mentioned, there is no need to even download the packages manually. We provide package repositories for a number of distributions that will take care of any package dependencies for you automatically. Okay, then, thank you very much for joining us, and I hope we see each other in a future webinar as well. Thank you.